Hello everyone. Welcome to the solution of LeetCode problem 117 named Populating Next Right Pointer in each node 2. In this problem, we are given a binary tree. The definition is for each of the node, we have the value left pointer, right pointer, and the next pointer. Now, we have to populate each next pointer to point to its next right node. And if there is no next right node, the pointer should be set to null. Initially, all of the next pointer is set to null. Now let's consider this first example. The root is 1, which has two children, 2 and 3. 2 has two children, 4 and 5, and 3 has one children, which is 7. So 1 is set to null because it does not have any of the next element. The next pointer of 2 is set to 3 because 3 is the next element of the 2, and the next pointer of 3 is set to null. And similarly, the next pointer of 4 set to 5, and the next pointer of 5 is set to 7, and the next pointer of 7 is set to null because it does not have any of the next element. I hope you understood the problem statement. Now let's move on to the algorithm. Here, to understand the algorithm, we have taken the same example. Now, what basically the problem tells us? It tells us that for each of the node, we have a next element or the next pointer, and we have to set it for each of the element. So the element 1 is set to null. And into the second level, we have two nodes. 2 is set to 3, or the next pointer of 2 is set to 3, and the next pointer of 3 will set to null. And similarly for the third level and so on. So as this problem, we have to deal with level by level. So we will use the BFS algorithm, and to implement the BFS, we have to use the queue data structure. Now let's see how can we solve this problem by using the queue data structure. Initially, we are at this element 1, and we have to insert 1 into the queue, and 1 has two children, 2 and 3. So we have to insert 2 and 3 as well. So this 1 is the only element into the first element or the first level. So this 1 is the last element of its level, so its next pointer is set to null. Now, the next level has two elements, 2 and 3. The current element is 2. So we have to remove it, and we have to insert both of its children into the queue for the next iteration, which is 4 and 5. Now, the next pointer of 2 will be connected to 3, which is the front element of the queue. Now, currently our front element is 3. So, does this 3 is the last element of its level? Yes, it is. So, 3 will be connected to null. Now, 3 has a children 7, so we have to insert it into the queue. Now, our third level has 3 nodes, 4, 5, and 7. So here, what is the front element of the queue? It is 4. So we have to remove it. And now our front element is 5. So we have to connect 4 with 5. And similarly for 5, we have to remove it and we have to connect 5 with 7. And 7 is the last element of its level. So we have to connect 7 with null. Finally, we have to remove 7 from the queue and the queue will become empty. So far, we have seen that we have manipulated the next pointer by using the queue data structure and the BFS algorithm. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. We are given a function named connect, which is given a root as a parameter. Now we are taking a queue to implement BFS and inserting the root into the queue. Now, while the queue is not empty, we are calculating the size of the queue, which is the size of each level, and we have to iterate for size of each level and store the front element of the queue into a variable current, and we have to remove it. And if the current element has left and right subtree, we have to insert them into the queue as well. Now, if the current element is the last element of its current level, so we have to populate the next pointer to null. Otherwise, we have to populate the next pointer to the queue front. Finally, we have to return the root. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.